Kumar, your maths guide. Welcome to my channel here for mathematics. Let us discuss about how to find the adjoint inverse of 3 into 3 matrix. Welcome once again. This is about adjoint of 3 into 3 matrix. To find the adjoint of the given matrix, what we have to do, we have to find the cofactors of the given matrix first of all. This is the given matrix and we know that here that there are 3 rows and 3 columns are there. We have to find the cofactor of each element. What is meant by cofactor? Cofactor is nothing but just we are taking the determinant of the particular element by leaving this column and this row. By leaving this column and this row. Okay, here the element here C3 represent cofactor of the element this 3. Okay, I have understood this one. This is the same thing follow for all the elements. Just observe the first row, then you can understand very easily for the remaining 2 rows. Okay, here the cofactor of the first element C3. How to find this one means here 3 is there means just delete this column and this row. Imagine that delete this column and this row. The remaining 4 elements are there 1, 1, 0, 2. You have to find the determinant of these 4 elements. That is what 2 into 2 determinant, and assign plus sign for this one. This is a very important thing. As it is, you are going on calculating for each and every element. You will be putting plus minus like that. Okay. So for that right time, now you have to take plus sign for the first one. Plus and the deleting corresponding column and corresponding row, you are getting the element, and you know how to expand determinant product of principal diagonal elements minus product of the secondary diagonal elements. 1 to the 2 minus 0 into 1 is 0, that is 2 minus 0, that is equal to, you got it as 2. Next, let us take the cofactor of the next element, that is the 1 here. Cofactor of this 1 is obtaining by deleting corresponding column and corresponding row. Then in the previous one we have taken plus, here you have to take minus sign. If you delete corresponding column and corresponding row, the remaining elements are minus 2, 3 and 1, 2. That is what I have taken, minus 2, 3 and 1, 2. Now expand this determinant, you will get it as 7. Similarly, cofactor of the element 2, that is by deleting this corresponding column and corresponding row, you will be getting the remaining 4 elements, that is minus 2, 1 and 3, 0. So what you will get, that is what you are getting by obtaining, that is a minus 2, 1, 3, 0. That is here previous one minus means here you have to take plus, that is plus product of principal elements minus product of the secondary elements, 0 minus 3, that is equal to minus 3. Similarly, next one, here you are entering to second row, that is the second row minus 2 first element, corresponding column and corresponding row you have to delete, that is you will be getting previous one plus is there means here you have to put minus. So write on the elements, then you can write the minus 2. Again similarly you have to take the another element, here central element is what, 1. Here it is a beautiful one, you will be taking the plus sign like this, delete the corresponding column and corresponding row. Remaining elements are what, 3, 2 and 3, 2. You will be writing 3, 2 and 3, 2. That is what here previous one minus means here you have to take plus sign. So after expanding you will be getting 0. Next is what, the second row, third element, delete corresponding column and corresponding row, you will be getting 3, 1, 3, 0. That is what, 3, 1, 3, 0, and previous one plus means here you have to take minus. So observe the pattern here, plus minus plus minus plus minus. This is the what pattern you have to take. Again we are having another row here, that is the third row. For that one what we will take, that is the again third row, first element 3. Cofactor of 3 means corresponding column and corresponding row. If you delete means you will getting 1, 2, 1, 1. You are taking the determinant of this element, you will be getting it as minus 1. And here previous one minus means here you have to take plus. Again another element 0. And one more thing here you have to listen carefully. What is that? Remember, if the element of the matrix is 0 means don't assume that cofactor will be 0. Okay, it is not at all possible. That cofactor also 0. That is not possible. See here you can see that here cofactor is of element is 0, but the cofactor is what? Minus 7. Remember this one. And the last element is that 2 is the cofactor of 2. That is what previous one minus. You are taking plus sign here by deleting the corresponding row and corresponding column. You will be getting remaining elements 3, 1, minus 2, 1. That is 3, 1, minus 2, 1. With the previous one minus means here you have to take plus. That is what you are getting the answer as 5. Okay. So next is that you have to write the cofactor matrix. How to write the cofactor matrix? Just write down what are the elements you got. For 3 you got 2, for 1 you got 7, for 2 you got minus 3, like that. First, that is what 2, 7, minus 0, you go on writing all the elements in the matrix form. This is called as cofactor matrix. Then how to find the adjoint of A? Adjoint of A is nothing but transpose of a cofactor element. So what is transpose? Already I explained in the previous videos. Transpose of a matrix is obtained by interchanging rows and columns. This is what transpose. We have to take transpose of this matrix. I have written the same matrix here. I have put the dash symbol. That is what you can take T or you can take dash, that both represent transpose, but don't write -1. If you are writing -1, that indicates inverse. Okay, so finally what we can write, that is the last one, that is adjoint of A is equal to, is obtained by the transpose of a cofactor matrix. You can see that here the first row, here it became the first column, second row it became the second column, third row it became the third column. That is what, how to find the adjoint of the 3 into 3 matrix. So let me explain one more example of the inverse of the matrix. Okay, here the same problem I have taken, so it is very easy to understand. That's why I have taken the same problem. Here what I have to find? I have to find the inverse. To find the inverse, the difference between the adjoint and inverse is that in the adjoint we are taking cofactor matrix, but in the case of inverse, again two concepts will be added. One is the determinant, other one is formula. First, whenever you get the matrix, to find the inverse, first thing is that you have to find determinant. So what is the determinant of the value? Here on expanding this one, you are getting it as 7. So the expansion of this determinant, I have some another say video for that one. It is not required to explain the expansion of the determinant. Okay, just follow that video. So here, that is, since determinant of A is not equal to 0, that's why it is got it as, it is a non-singular. Already I explained that in previous video, what is mean by non-singular matrix and what is mean by singular matrix. And remember that one, what do you mean by the singular matrix? It is the determinant is 0. If it is non-singular, not equal to 0. And the condition for getting the A inverse is the next steps. Okay, again finding the cofactors, already I explained in the previous problem in this video itself. You can go through that one. Same problem I have taken, so it is not difficult to understand that one. So we got the cofactor matrix. Adjoint is equal to transpose of cofactor matrix. Adjoint, I got the adjoint. Now the difference is that we are getting A inverse is equal to adjoint by determinant of A. So just substitute in this formula, you will be getting it as A inverse. So here you have to understand properly that difference between adjoint and A inverse. In the case of adjoint, adjoint is a part of A inverse. Okay, so without calculating adjoint, we cannot be able to calculate A inverse. In addition to adjoint, we have to calculate determinant also for calculating the A inverse. If you want, I can explain how to skip the 3 steps here. You can skip this cofactor matrix and adjoint transpose of C, and writing the transpose directly you can write the adjoint of this one. How to write this one? It is very simple. Here whatever the elements we have written in the row wise. 2, 7, minus 3. I have written it as 2, 7, minus 3 as row. Instead of that, take the group of 3 elements, whatever you have calculated cofactors, put it into the column form. See, the 2, 7, minus 3 I have taken in 2, 7, minus 3. Again minus 2, 0, 3 I have taken in the minus 2, 0, 3 as I have put it as column, and the remaining 3 elements again minus 1, minus 7, 5, put it in the form of column. So directly you can be able to write the adjoint of A. Okay, so this is about how to find the adjoint of 3 into 3 and inverse of the 3 into 3 matrix. Thank you very much, and please don't forget to subscribe my channel. Thank you very much.